Hi everybody, my name is Marius. As you can see today I'll be doing a very quick video on ABCs of ADVPN on HP routers. That's a lot of words. Okay, I'll explain everything just now. Okay, anyway, welcome back to the ABC networking community. I've gone around, I haven't seen much around ADVPN. I'm seeing a lot of customer interest in ADVPN today. Right, this is not a shootout. Once again, you guys know me already. I don't like shootouts. You know, you buy because you like a product. I'm not going to try to convince you what it is. But once you've made your mind up around, you know, an HP type solution, you've got a couple of things you have to think about. This video is not necessarily to talk about all the benefits of ADVPN, although I'll mention a couple of them as we go through the video series as we move forward. It's more a case of, you know, I get a lot of customers, by the time I speak to them, they've pretty much made up their mind. They're going to go with a specific type of solution like the ADVPN on HP router. And they're happy moving forward. However, they're a little confused sometimes about how this solution works. That is quite different to other vendors. Like I said, not a shootout. Let me rather just discuss what HP is doing around this space. At least my understanding of it. Right, so from that point of view, like I said, you've now made a decision. You're going to go with ADVPN, and it's an automated device. You know, it's an automated system that they use to build an overlay network. As I move through the videos, you know, I've got some configuration videos that we'll do. If you've ever seen my videos, I really try and simplify things. I don't try and complicate it to look impressive. I'd rather simplify it, you understand it, and move forward. I think one of the biggest catches with things like ADVPN is that a lot of people go and they copy and paste the configurations, and it's quite sad without quite knowing what's going on. So let's see if we can help you with that. Okay, so getting into the next page then, I just want to select a pen here quite quickly, like a proper line. Okay, so looking at this effectively, what we have is we've got an infrastructure. Why ADVPN? Very quickly, I've got a customer edge, right, that's maybe connected to MPLS cloud, right, at the same time this guy's also connected to, let's say, a 3G /4G /ADSL, whatever the case may be. Yep, okay. So this interface there is very predictable. This interface there is not that predictable. Next thing about this interface over here, alright, let's just choose a different color. This interface over there is that it should be relatively secure because you're running an MPLS infrastructure over there. But these days you'll see a lot of customers saying, no, we prefer to run an overlay network here. So what the customer has is they've got a private network, which we call a private, right? And of course you've got an overlay, basically public network here. Public network, yep. So what they want to do is, and you'll see this happens, is they basically want to connect onto a head end, right? So let's say this is the data center router for now. Okay, and this guy's also connected somehow to these infrastructures. What they're saying is, well, this is a private network. Number one, I don't want this private network to appear in this infrastructure here, the service provider network. Okay, what I want to do is have quality of service, everything good, but this is mine. Okay, I know we've got, of course, ways of doing it in MPLS, you know, with multiple VRFs and so forth, VPNs, whatever vendor you're talking about. Okay, but not all customers like that. What they want to do is they want to build a secure tunnel. I'm going to go to a different color there. They want to literally build a secure tunnel across this infrastructure. Okay, now there's multiple ways of doing that. Well, one of the ways we can do that is through something like a GRE tunnel, right? We've seen that. You can use IPsec. We've seen that. This is quite complicated though, yeah? And we've seen a combination of the two, all right? But these are all manual type setups. When you move into an automated, so it means that if I create a tunnel, I have to create a tunnel endpoint and a tunnel endpoint. Between the two, with IPsec the same thing. I'm going to expect a specific type of IP address along the way. Now when I'm saying expect, right, that puts a lot of pressure on my infrastructure. Because if I'm expecting a certain IP address, for instance, for IPsec, right, so I can terminate the tunnel for it. If this is a 3G, 4G, ADSL type solution, I can't always guarantee my IP address. So I've got dynamic IP addressing that could change along the way. That poses a lot of trouble and issues within this infrastructure, right? If you have the manual GRE, because there's ways of getting around it, but it creates a bit of complication. Okay, so this is what we talk about, right? This is when you get into the ADVPN type solution, ADVPN. And as we go through the configurations, you'll see what I mean. Okay, it's not that restrictive in the way you set it up. Alright, so it doesn't have to go from a specific IP to a specific IP, and also the configuration is very easy once you've set it up initially to move into adding additional tunnel, or let's call it customer edge routers, which will have additional tunnels. It's much easier to set up. Okay, so let's quickly just clear this off so I can start again. So how does this whole system work? Well, effectively, let's quickly draw this out. Okay, so you've got a customer edge, like we said, customer edge, and you've got a data center. Somewhere along the line, you've got a service provider. I don't care at this point what the service provider, what they offer, what they don't offer. I don't care if it's 3G, 4G, MPLS, what the case may be. I'm not going to go into that. So let's say this is some type of LTE service provider. So he is connected as with a backup interface over there. He's connected with a primary interface, and of course you've got the hub side. All right, let's call it hub for now. We'll get into the wording, is very important. All right, and this is the spoke side. Okay, so like we said before, we can either know or not know the IP addresses, doesn't really matter. The first thing you want to do with an AD VPN solution, the number one thing you want to do is make sure that you have WAN connectivity. That's important. Okay, so I should be able to ping from this interface and ping my hub. I should be able to ping from that interface and my hub. I'm not talking about the inside, I'm talking about public, the WAN, okay, connectivity. A lot of people copy and paste and things don't work and they don't even know where to start, and they don't even have WAN connectivity yet. So whatever protocol you decide to run here, OSPF, BGP, statics, doesn't matter. As long as you actually have connectivity, and that's the rule if you want to move over to AD VPN. Yep. Now the next thing that happens is you're going to have to somehow match a private network with a public IP address. It's easy if this IP address is predictable. It's not that easy if it's not predictable. Let me explain. Predictable is when I actually have an MPLS network. I've got a range of IP addresses. It's inside an actual MPLS infrastructure. That's very predictable. But if it's not, it's like the internet type environment, then it's not that predictable. Okay, so I want to somehow match my private address, which is a non-routable normally through the WAN IP address. Let's say something like a 192, or a 10 or a 172, whatever the case may be, address. I want to map it to a public routable WAN routable address. This is like a 178 address, or whatever the case may be. That's your service provider will provide that address to you. It's a routable WAN address, so you have to somehow match the one with the other, and make sure that's routable. So from that point of view, like I said, we're going to go into the ADVPN solution. What ADVPN brings to the table, HP, is something called a VAM server. It's an address management server, It basically manages addresses. So from a infrastructure point of view, what you'll find is there's three components, very important components to an ADVPN solution. The first thing is a hub router. The second thing that you have is you've got the spoke, and then the third thing is the VAM. Now if you look at the configuration, the second thing you will do is that you need to know, well, it's WAN connected. This guy has got to be routable somewhere along the line on the service provider. If he's not routable, there's no way this spoke can get to him via a WAN interface. Okay, so that is very important. At the same time, you'll see that they will share an actual LAN interface. I'll show you with the configurations. There's reasons for that. So effectively what would happen is the first thing in this configuration examples would be the VAM server would be set up, and the type of router and so forth is important. We'll talk about that as we move forward. But the VAM server basically holds a table, of IP public to private addressing per spoke, spoke. So for every single spoke, there will be a private to a public addressing scheme. So along the way, as you add new devices to this, I don't have to go and change his configuration. I don't have to worry about routing protocols or anything like that. All I got to do is, if this is spoke 2, I'm going to point him to the VAM server. He will start initiating an actual call to the VAM server. He will tell him about my public IP address that he has and his private address, and he'll create another entry. So this guy starts to create entries and multiples of them. So that's the VAM server. So that's very important to know, that where the VAM server basically plays, that's the key server. Yeah, that's a very important key server inside this infrastructure. Right, the hub itself, depending on what type of infrastructure you set up, you can actually have a hub and spoke type scenario, hub to spoke, or you can actually have a fully mesh, which is spoke to spoke environment. Right, what I mean by that is you can have all your traffic from spoke 1, spoke 2. Let's change color. Let's say this guy wants to go from, there's a PC sitting over there and there's a PC sitting over there, and they want to talk to each other. Right, in a fully meshed environment, basically what would happen is it would do this. When I say that, it goes through one of these two service providers, whatever infrastructure you have available. Okay, that's a full mesh. A hub and spoke environment is basically, they still want to talk to each other, but they will go through some type of hub, and from the hub it will come down again. Right, so all traffic from this guy to this guy will be through the hub and spoke, right, environment. You can also have a partial mesh environment where some of this is fully meshed and some of it is hub and spoke. We're not going to go there now. I'm not talking about the advantages, disadvantages of either one of the two. You need to know before you start your deployment which one you want. Okay, so everybody is going to go, ah, yeah, full mesh. If you've said that, you must probably be a routing engineer, a networking engineer, right? Okay, if you've said, no, I like the hub and spoke, you must probably come from a security background. Okay, remembering that the more connected you are, the more difficult it becomes to secure. Okay, you can't create choke points. If you're a security engineer, you want to cut down on your connectivity because you want to control the flow of traffic. Okay, so that's one of the major disadvantages of a full mesh network today. I don't care what type of ADVPN, DMVPN, I don't care. Okay, full mesh is secure thread. Okay, for simply, if this guy starts to attack and he's got access, he can actually build tunnels to 3,000 of your edges. It becomes very difficult to stop him from doing something. Right, however, if he's going to come through the hub to infect all the other guys, it's quite easy to stop him from getting into the central location. Okay, so there are advantages and disadvantages of the two. What is the difference does it make to the VAM server? Nothing. Zero. Whichever solution you choose, it won't change the VAM server configuration. What determines whether it's hub and spoke or a full mesh topology is the way you set up the IP addressing of the tunnel interfaces. Right, number one, and number two is the way you do your routing. It could be as simple as on your routing protocol, like OSPF, on a specific port, you would say point to point. And in that case, it's a hub and spoke environment. If you say point to multi-point, it becomes a full mesh environment. As simple as that. Really, it's not that complicated. Okay, so I want you to remember all of this as we move through the actual design going forward. Right, the one thing I do want to talk a little bit about is the VAM server. So let's quickly erase this. So the VAM server, we've now realized, is quite a key device. Yep. So what do we use as a VAM server? Well, there's a cool thing called a VSR, a virtual services router. And the one thing that we have figured out about a VAM server, it's a transactional server, a transactional router. Now, a transactional router basically does two things. It understands the routing business very well, but more importantly, it builds a lot of tables. Right, and these tables are all built in RAM. If you take a big router like whatever you want to buy, whatever router that is, typically a router is really focused on routing data. Yep, traffic comes in, it makes a decision and fires out. That's what it's designed to do. So how much RAM do you need for that? Well, you need some tables depending on the size of device you want to use, yeah? So you want to get some tables going and so forth, yeah? So typically you do those tables in RAM, and there's a finite, very finite amount of RAM you can build into routers. And depending on the model you're buying, money, you know, the higher you go, the more RAM you can put in. But RAM is very, very dear in the routing concept. Okay, that's very expensive. We know that today already. All right, there's workarounds for that, but let's not talk about that. Anyway, so from that perspective, what we found was with the VAM server was, what if you could put that onto a VSR? VSR is a virtual services router. You put it into a, let's say, a DL380 server. What do we know about RAM in servers? Wow, they're really cheap compared to this solution. How much RAM can you build into a server? Well, it really depends. Okay, you can go into gigs and gigs of RAM. So you can really populate this with a lot of RAM. 32 gig, 64 gig, whatever you want to do, 128 gig. Right, which gives you a really nice big table that we need. Right. The other thing about that, I can put a lot of table in there. So I take care of the routing concept on the VSR. and by the way, this is a 20 gig router. I take care of the VSR, it takes basically care of that, and I can build really big tables. So this becomes a phenomenal VAM server. That's why I call it VAM server. Okay, so it's a router, it's a virtual router that runs on a server with lots of RAM, and inside the lots of RAM, right, we've got the routing component, which is fine. It's got throughput potential, and at the end of the day, it can hold really large tables, which means that this works for scalability. You can really scale out the network. And this has been one of the drawbacks of an automated design like this, because that one device that knows everything, right? You can do it one of two ways. You can either have all the routers know everything, link state type environment. What's the disadvantage of link state? If something changes, it's a lot of routing updates, it's a lot of processing power, which means you need quite a big router. So when you build this infrastructure, the last thing you want to do is, from a customer edge point of view, have a really large customer edge router, because you need to hold 3K routes. Right, that every time something changes, it's going to rebuild the routing table. OSPF, yeah. Remember, so that's not cool at the moment, right? So what you want to do is, maybe you want to have a default gateway and something sending, but now you're starting to say, well, somebody else needs to know all the information. Because if you've got 3,000 routers, right, and you want to talk to somebody, it's almost, and you want to talk to him directly, how's that possible if you don't have a routing table entry? Okay, so this is a scalability issue. So then somewhere along the line, you need a device that knows how to get to that infrastructure through a publicly routable interface, and that's called the VAM server. Right, so like we said, is we can really build this guy up quite well. All right, keep this router quite small and still be scalable. All right, that's how you can get into thousands of sites, all right, without building or breaking this guy's backbone, okay, and breaking his RAM installation. So that's what I'm talking about from that point of view. Right, so the VAM server is key here, very important. You'll see that they will suggest that you run it on an actual server with lots of RAM in a large environment. Right, and of course you can have basically two of those. Okay, so let's clear this up again quickly. So let's build a standard network now. Okay, so what we said is, you've got a hub. The hub is connected to the service provider, yeah, infrastructure. And there you've got, let's say, two spokes. Spoke 1 and spoke 2. Like I said before, you need a VAM as well. So let's say that's VAM 1, and that's connected over there, and this is an infrastructure. What people started realizing was, even though, you know, depending on the routing protocols, even though you had this VAM server in play, you would still have to know a lot of routing inside this infrastructure, yeah? So if you used OSPF, we all know about the limitation of OSPF at a specific time. It's not useful using OSPF anymore, right? So people started looking at BGP to run this. BGP is slightly more complicated. I'm talking about in this overlay type network, yeah? BGP gets a little bit more complicated and so forth. But more importantly is, the higher the BGP routes, the lower the performance, which means the higher type of router I've got to use. This goes up. Okay, so how did they solve this problem with OSPF? Well, it was very simple. What they created was an actual area 0. Right, and let's say this was all part of area 1. This becomes an ABR, a area border router, yeah? Which means that he knew everything about the rest of the world, and these guys only had to know what was going inside this area. This brings me on to the next type of design that HP has brought out. Okay, you'll see that they talk about these areas. So what they do is they say, well, you can start with one hub. As a backup, you could have, that's hub 1. This is hub 2. Right, because if hub 1 fails, you want the backup infrastructure, right? There's a LAN infrastructure, and I'm going to put the VAM servers in between here, VAM 1, and of course you can have a backup, VAM 2, and you can actually have a bunch of spokes here. And let's say this is one country, one regional area, whatever the case may be. I'm just going to draw a line down there, right, and another line down there. Okay, so what you do is you get these guys to build tunnels, right, as they would do, permanent tunnels, right, and if they need to talk to each other, they will basically have the information, because this is all part of a specific group. So if I did this, and we say this is group 2, that's the reason I'm calling it group 2. At the same time, if you wanted to actually scale this out into another country, another regional area, another department, whatever the case may be, you could put another 2 hubs down here, hub 3 and hub 4. Okay, and you could add a whole bunch of routers over there, right? And they are all interconnected. I'm not going to draw all the lines. You get the point. Okay, so that's interesting. Say the only way I can get this done is if this router knows a lot about this whole infrastructure and the VAM server is in place. Okay, because if this guy wants to talk to that guy, it's easy enough. It's within the same group, right? He'll have the data, and if he doesn't have all the data, the private addressing, he'll just go to the VAM server. He will tell him where to go, and you'll go right there. You'll see with the routing protocols later on, they actually know how to get to each other, to the private networks. However, they will not necessarily know what's going on the other side, depending how you've set it up. Okay, so this is where things get interesting. Is if you want to talk from one group to the other group, but you only have information about this infrastructure, all right, you need to go through a common group, and this is where I'll call this group 1. Group 1, what's the rules about group 1? These hubs, almost all of them, live in group 1. So this group 1 will run across the board. Okay, and the key here is they have to be fully meshed. He's got to be connected to him, he's got to be connected to him, and he's got to be connected to this guy, and he's got to be connected to that guy. So if you add another 2 hubs over there, same rules apply, yeah? You happy? Okay, and they're all connected. So this is a fully meshed. This must be fully meshed. This doesn't have to be. Okay, you could have this fully meshed over there and fully meshed over there. That's fine. So could you end up sending traffic across from one to the other? Yes, absolutely. We'll show you how later on in configuration, which means that you can actually make this a very scalable infrastructure. It follows a lot. It looks a lot like OSPF and groups, right? Areas within OSPF. That's when they talk about groups. So what I'm going to do, you know, in my next couple of videos, I've already started setting it up, is we'll start with the simplest version of this. I'll start with one hub, hub 1. There's no backup hub. The reason I'm doing this is so you can understand what's happening, the flow of traffic, right? Because you'll see, I'm going to explain it to you now, and then of course the next video we'll actually do the configuration. I'm going to start with one VAM, VAM 1, and I'll have 2 spokes, spoke 1 and spoke 2. Only once you understand the flow of traffic will we move on to the next component. Alright, that'll be connected to each other. This will be connected there, 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 and there. Right, you'll have a LAN infrastructure, you'll have a LAN infrastructure that's private, private, and that's private as well. Right, so from that point of view, this will be the 192.168.100 network, and this will be the 192.168, if I remember, 36, 192.168.37 address, yeah? Everything in between here, this part there, I want to say this WAN part there would be running OSPF, because I can. It's easy enough. I could run anything there. It doesn't matter. Remember, the important thing is that this guy can ping that address, and that address. That's important. Yeah, he needs to be able to get there. Then, of course, we'll look at this and say, well, how does the traffic flow? Well, if S1 wants to talk to S2, and we've set it up with BGP and so forth, the flow of traffic, I'll just quickly talk about that. I want to talk from a device over there to a device over here. Alright. Even though he has a route, you'll see in his routing table, if we've set up BGP, because BGP will be running an autonomous system. So I'm just going to say this is autonomous system, let's say 101, and this would be running an autonomous system 100, which means I'll be using eBGP, right, for my tunnels, because this guy will build a tunnel over there, and he'll build a tunnel over there. There is no tunnel from there. So the flow of traffic, very simply, first this guy hits the router says, oh, I've got to go to 192.168.37. He checks his routing table. In his routing table it says, yes, you can get there via this tunnel interface IP. Sounds interesting, yeah, okay. So it means that there is something in play here. Okay, so what he does is, he says, well, okay, that's my tunnel endpoint interface, so he goes and talks to the VAM server. Ask the VAM server, hey, by the way, do you know how to get to 192.168.37? VAM server looks at this public IP address because he's got it in his table and says, yeah, of course I know how to get there, and fires this back and says you can talk to him directly. Alright, and because they share this commonality with IPsec and so forth, they actually then start to talk to each other. So the data, this is basically your setup. Okay, your data will flow directly between spoke 1 and spoke 2. It does not hit this interface at all if it's a full mesh environment. Won't go through there. Okay, so it goes there directly. And what you'll see is if you actually look at the debug there, the debug will actually say it's going to transform that IP address into this IP address as a next hop, and it basically fires the packet across directly. Okay, once I've shown you that, this is basically, I want to call it phase 1. It's all about connectivity. We'll move into phase 2, which is all about redundancy. Right, well, what if this router there dies? What if this VM server dies? What happens then? Okay, so what we'll introduce is we'll introduce a second hub, hub 2, and we'll introduce VM 2. Only once you understand the flow, because nothing else will change in the flow. The flow will be the same. And that's important to understand. So once you understand that, you can start to predict, you know, how to do that. That'll be the connectivity phase then. All right. After the connectivity, we've done that. You want to get, like I said, into redundancy. That will be phase 2. Phase 2. Right. And phase 3, effectively, we can start to get scalability. Okay. Scalability is when I create multiple groups, and then, of course, the information between them. Okay. So I'm hoping you will watch the other videos. Please let us know by comments whether you find this helpful or not. Alright, this is not a config video, like I said. There will be another video following up. I don't want to make the videos too long, right? Because there's some people who only want to see the configuration itself. Okay, thank you very much for your time. Appreciate it. Hope to see you in some videos in the future. Cheerio, bye-bye.